Welcome back. In this video, we are going to solve example 3.3 that is taken from chapter number 3, Mechanical Properties of the Materials, and book name is Mechanics of Material by RC Hibbeler, 9th edition. So statement of the problem is an aluminum rod shown in figure 3-20A has a circular cross section and is subjected to an axial load of 10 kilonewton. If the portion of stress strain diagram is shown in 3-20B, determine the approximate elongation of the rod when the load is subjected. Take aluminum, modulus of elasticity of aluminum is 70 gigapascal. So you can see this is the rod, that is step rod having 10 kilonewton load, tensile load. The diameter of this portion AB is 20 millimeter, while the diameter of portion BC is 15 millimeter. And this is the stress strain diagram for this aluminum rod when it is subjected to load. So you have to determine the elongation change, total elongation in this rod due to this 10 kilonewton load when it is applied on this aluminum rod. So let's start with the solution. So first we can see that for analysis, we will neglect the localized deformation at the point of load, as well as we will neglect the sudden change in the cross-sectional area at this point, because at this point we will have stress concentration. So we will neglect them and we will find the stresses in this both portion AB and BC. So let's start with the finding the load in portion AB and BC. So I will cut the portion AB. So I will write it for portion AB. If I draw the free body diagram, so this is the rod. So at this point we have 10 kilonewton load. Clear? So here what will be the load? Let this load is P. So by using equation of equilibrium, that sum of all forces along x direction must be equal to 0 and force toward right is taken as positive. So minus 10 kilonewton plus P is equal to 0. So from here you will find that this P will be equal to 10 kilonewton. Now what we will do is that we will find the same load for portion BC. And for portion BC, you will cut this portion BC and draw the free body diagram. So it will be like the same. Here you have a load of 10 kilonewton. Clear? So here this load will be equal to, let this will be equal to PBC. I can write it over here to differentiate PAB. So we will find this PBC by using this equation, and it will give you the same, that minus PBC plus 10 kilonewton is equal to 0. So from here you will get this PBC will be equal to 10 kilonewton. Now you know that both rod is having the same load, that is 10 kilonewton load. So what we will do is that we will find the stresses in portion AB and BC. So first we will find for portion AB, we can say that stress in AB will be equal to PAB divided by area of AB. So PAB is this one. You can see this is 10 kilonewton. So 10 into 10 raised to power 3 will give you Newton divided by area. So you can see diameter of this is given as 20 millimeter. So this diameter in meter will be equal to 0.02 meter. And what we can write is pi diameter is equal to pi by 4 d square. So d is 0.02 square. Okay. So when you solve this, you will get 31.83 into 10 raised to power 6 Pascal. And when you solve it, and you can write it as that 31.83 megapascal. This is the stress that is generated in portion AB. Now for portion BC, we can find stress in BC is equal to load PBC divided by area of BC. So you can see this is the load PBC, which is again the same 10 kilonewton. So 10 into 10 to the power 3 will be Newton, divided by the diameter of this rod is given as 15 millimeter. So it is 0.1015 meter. So area is pi by 4 d square. So pi by 4 0.015 square. So when you solve this, you will get stress will be 56.59 into 10 to the power 6 Pascal. And in megapascal, this stress in portion BC will be equal to 56.59 megapascal. Now you have this stress. So what we will do is that from stress strain diagram, you can see the yield stress is 40 megapascal. So I will write it from stress strain diagram. Sigma yield is equal to 40 megapascal, and you can see that sigma AB is less than sigma yield. Sigma AB was 31.83 megapascal, and that is less than 40 megapascal. So mean that portion AB is in elastic region. So what we can see, we can write it that here we know that stress in AB is equal to E into epsilon AB, because this is in elastic region, so we can apply Hooke's law. So what we will get is that strain in region AB will be equal to sigma AB divided by E. So put the value sigma AB is 31.83 into 10 to the power 6 Pascal. And what is E? So E is given as 70 gigapascal. So I can write 70 into 10 to the power 9 Pascal. So when you solve this, you will get this strain in portion AB. Strain in portion AB will be equal to 0.0004547. You can also write millimeter per millimeter, or this is simply just a number. Now for portion BC, we can see that for BC, we can see that stress in BC is greater than sigma yield. Clear? So this is in plastic region, and you can see that this is in plastic region. This is sigma BC, that is already shown over here. So we cannot apply the Hooke's law. So what we will do is that we will take the value of strain for this sigma BC, and this is strain BC is equal to 0.045. So from stress strain diagram, this strain BC comes out to be 0.0450 millimeter per millimeter. Now for finding the approximate elongation, so I will write it, the approximate elongation in the rod will be equal to delta, and that will be equal to sum of epsilon into length L. So I can write for epsilon AB into length of AB plus epsilon BC into length of BC. So delta will be equal to epsilon AB is 0.0004547 multiplied by length of AB, which is 600 millimeter or 0.6 meter. Okay. You can also write in meter, but I will take here 600 millimeters. And plus epsilon BC was 0.0450 multiplied by length of BC was 400 millimeter. So 400 millimeter. So when you solve this, you will get total elongation in this rod when subjected to a load of 10 kilonewton will comes out to be 18.3 millimeter, which is the answer of our this question. So due to this loading of 10 kilonewton, you will see that there will be elongation of 18.3 millimeter occur in this aluminum rod. And that was all about this example 3.3. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Thank you for watching.